Hello everyone, myself Janisha from St. Joseph Composite PU College, Vijaypur. I'm dealing with economic subject. In the last episode, we have discussed about the frequency distribution, and also in that we discussed regarding the parts of frequency distribution, and we came to know about the meaning of class interval, class width, class midpoint, class limit, etc. Today in this episode we are going to discuss about the loss of information. As you know that, dear students, the classification of data, the arrangement of data or the classification of data. The classification of data as a frequency distribution has an inherent shortcoming. That means while arranging the data or organizing the data which have its own shortcoming, while it summarizes the raw data, making it concise and comprehensible, it does not show the details that are found in raw data. That means while we summarizing the things or while we concluding the raw data, and it concise and comprehensible, so it needs to maintain the concise and comprehensible, and it does not show the details that are found in raw data. And there is a loss of information in classifying raw data, though much is gained by summarizing it as a classified data. And also there is a loss of information. In such a situation, there is a loss of information is classifying raw data, though much is gained by summarizing it as classified data. That means while we classifying the data, we can get a more number of informations. Once the data are grouped into classes, an individual observation has no significance in further statistical calculations. That means once the data are grouped into different classes, then individual observations has been ignored, that is particularly in statistical calculations. So this situation is what? Loss of information. Next we'll discuss about the frequency distribution with unequal classes. By now you are familiar with frequency distribution of equal class intervals. You know how they are constructed out of raw data. But in some cases, frequency distributions with unequal class intervals are more appropriate. That means not unequal class intervals are more appropriate. Then let me discuss about the frequency array. For a discrete variable, the classification of its data is called as frequency array. So frequency array means what? In a discrete variable, the classification of its data. So the classification of data in a discrete variable, that is what? Frequency array. Since a discrete variable takes values and not intermediate fractional values between two integral values, we have frequencies that correspond to each of its integral values. Means discrete variables takes values and not intermediate fractional values. We know that already in a discrete variable there is some restriction will be there. There is not allowed a fractional values. Yes, so in such a cases we have frequencies that correspond to each of the integral values. So this is what the frequency array. Okay students, now let me discuss about in detail regarding the frequency distribution. In a frequency distribution, there are two types. One is univariate frequency distribution, another one is bivariate frequency distribution. Then what is bivariate frequency distribution and where we can use the bivariate frequency distribution? Very often when we take a sample from a population, we collect more than one type of information from each element of a sample, right? That means if you want to collect the informations of particular things, then you need to collect more number of informations. For example, suppose we have taken sample of 20 companies from the list of companies based in a city. Suppose that we collect information on sales and expenditure on advertisements from each company. That means we collect the informations as much as possible. We must collect the informations more. In this case, we have bivariate sample data. Such bivariate data can be summarized using a bivariate frequency distribution. Thus, then what is bivariate frequency distribution? So, bivariate frequency distribution can be defined as the frequency distribution of a true variable. If the frequency distribution of two variables, then it is called as a bivariate frequency distribution. The values of sales are, now let me discuss how this bivariate frequency distributions are collected. The values of sales are classed in different columns and the values of advertisement expenditure are classed in different rows. And each cell shows the frequency of the corresponding row and column values. That means in a bivariate frequency distribution, here we made a separate informations in different ways, and also here we make columns, different columns for according to that example, that is values of a sales, and also that is in the another one in a row side we put the advertisement expenditure, and also from each cell shows the frequency of the corresponding row and column values. So this is what the bivariate frequency distribution. Along with univariate frequency distribution is nothing but the univariate frequency distribution is nothing but the frequency distribution of a single variable. If the frequency distribution of single variable is called as a univariate frequency distribution, and if the frequency distribution of a two variable, then it is called as a bivariate frequency distribution. So this is what regarding the frequency distribution. Now we'll conclude this chapter here. Thus we can say that the data collected from primary and secondary sources are raw or unclassified. Once the data are collected, the next step is to classify them for further statistical analysis. And this chapter will give idea about the classification and brings order in the data. So this is what the chapter of organization of data. Now we'll move some exercise questions regarding this chapter.